Hello everyone, this is Nilesh Gule. Welcomes you to the class of File IO using C#.NET. In this particular class, we will talk about the File IO, streams, and serialization. File IO is one of the tricky concepts in the .NET or even other programming languages, and there is always a lot of confusion. But you need not to worry. In this particular class, we will try to cover all major and important parts from the file IO, streams, and serialization. And we will start with some absolute basic question. And the basic question is, what is basically file? So file is collection of data and information on a storage device. When I talk about data and information, there are two things. The data over here is basically the contents and information is basically the metadata. Let me make it simple for you. If you double click a file, it gets opened in some software, and then whatever you see over there is the data or content of the file. But when you right click it and go to the properties, whatever you see is basically the metadata. This metadata includes the name of the file, size of the file, user of the file, and other file attributes. When we talk about the file IO in general, we talk about both these things. We talk about the data read-write operation inside the file. At the same time, we also talk about the metadata manipulation, where we can change the username, or we can try to change the timestamp of the file, or we can rename a file, or we can do some basic operations like deleting a file or creating an empty file. That part typically come in metadata manipulation. Let me tell you about both the things. The majority of classes we are going to see for file IO, they are part of System.io namespace. For doing these file IO, there are helper classes. That is the easiest way of doing file IO in .NET. And two helper classes are there. First one is file and second one is a directory. Now, both these helper classes have plenty of static methods, and these static methods are used for doing many different tasks. Let us take a look at the few important methods from these helper classes. You can check that we have a method like file.exist to check whether the file exists or not. Or we can create empty file using file.create. We have file.delete to delete a file. Then there are methods for reading the text from the file, or writing the text to the file, or appending the text to the file. There is also method to check whether the directory exists or not. There is also method to create the directory, delete the directory, get the content of the directory, to get all the files or directories from that directory. And also we can get the logical drives like C drive, D drive, and so on. Instead of trying all these methods one by one, let us take one mini problem statement and try to look at the important methods from these helper classes. So consider a simple problem statement. I have already created one console application for you, and inside this console application, you consider this problem statement where we are supposed to input a path from the user. It can be a file path or it can be a directory path. If the path is /, then I need to print all the drives, C drive, D drive. If it is a path of a directory, I want to list all the files and subdirectories in that particular directory. And if it is a file, I want to print its content. Finally, if it is not a valid path, I want to print the error. So let us start doing it step by step. First thing, I want to take the input from the user, where I can ask user to enter a path. Let me take the path by using console.readline. And then we can check over here if this path is /, then I will use the method directory dot get logical drives. This particular method returns the string array. So I will collect that strings array and then we will print it. So string array drives. We can use a simple for each loop for printing all the drives. Let me print it like drive. But if it is not slash, then I need to check if it is a directory or not. And that can be done by using the directory.exist method. So I can use else if directory.exist, then I want to get the content. For that, there is a method directory.getFiles, which again returns the string array and it contains the file names. It contains the full file path actually. But remember that getFiles only gives you the files in that directory. It doesn't show the directories or subdirectories over there. If I'm also interested in getting subdirectories, then I need to call directory.getDirectory. And from that, again, I can use for each loop and I can print all the directories from that. Now, if I have now the file as well as directory, we can go ahead and we can also think of how to get the content from the file. And for that, again, it is very easy job. We have the ready-made method like read all text. So we can try to use that simple method saying that file.read all text, which will return you the content and you can print that content. This is one way of doing it. If you do not want to print the whole text as a single string, then you can get it as string lines. And that can be done by using read all lines, and which is returning me the string lines array. Again, I can use for each loop and I can print all the lines. Now it is your choice which method is more comfortable to you. And finally, if none of these conditions are true, then it is invalid path. If it is invalid path, I will just put a message saying that this particular path is not valid. Let me try to run this and let me check if it is working well. So let me run this and let me check if I give a slash, then it should show me the drives in my computer. Yes, in my computer, I have C drive, D drive, and E drive. That's great. Let us go ahead and try to give some directory path. I'll have a simplest directory path. Let me get the path of this particular directory itself. So I can get copy full path and let me run this. Let me give the directory path, which is FileIO directory path. And it is showing me these are the files program.cs and FileIO.csproj. And bin and obj, these are the directories in that particular directory. What if I want to get the file contents, then I need to give the path of the file. Let us again consider this one where we are getting the full path. Let me run it and let me check. Now, whatever code that we had written, it is program.cs. I have given exactly same path that itself is a file. So it will actually print the whole code over here. And at the end, what if I give entirely wrong path like D colon and I'm writing something A, B, C, D, E, F, G. Now what will happen in this particular case? There is no such directory present and it will give me error like it is invalid path. So over here, we try to see some of the important method. You can always go ahead and try to check the other methods from these classes. You can refer to documentation for that. Though there is easy way of writing data into the file using file.writeAllText and reading data from the file.readAllText. These are just helper methods. Behind the scene, the data is read or written using other special classes which gives you the better control on the data write and read operation. And over there are two types of data reading and writing is possible. One is text file IO, where you can write the text and read the text. And then we also have binary file IO, where we can write the data in binary form and we can get that data back. So let me give a try on this. Let us try to check how we can use this StreamWriter and StreamReader class to write the textual data. Let me quickly tell you the basic difference between the text data and binary data. The text files can be opened in any simple text editor like Notepad, and you can read the whole content. It is very much human readable. This is the plus point of it, but minus point is that this particular data need to be always parsed. And if that data need to be parsed, it is usually slower execution. While the binary file IO, where you are writing a data into the file, this file may not be human readable. So if you open that file in the notepad, you might see some garbage characters. However, the data is kept in a binary format, exactly same way how it is kept in the memory. And while reading, the reading will be much faster because it is not doing a kind of a parsing logic over there. So I told you the text file and binary file difference. Let us try to implement both of them one by one and see how simple both of them are. So let me take you back, and instead of just writing some code and writing some integer or some float or some double, let us take some simple example and take some meaningful data that I want to write it into the file and then I want to read it back. For that, I will consider one class called as a class person. And in this class person, I will take some members like one string name, another one it can be age, another one you can consider like an address. And if you want to add some more members over there, you can add. Let me override only one method over here. And that method is nothing but toString method. And in this toString method, I will only write the code like printing name, age, and address. Let us create another main. And in this main, we will create one object of the person and we will try to write the data into the file. We will also read the data back. Let us do it step by step. First, let me create a person. Person P is equal to new person. And inside this, I will write, let's say name is equal to something, age is equal to something, and address is equal to something. If I want to write this data into the file, then there is a class called as a StreamWriter. StreamWriter is helpful for writing the data into a text file. Over here, I have given the name of the file as person.txt. You can note that I have not given any path. So by default, it will get created in the current directory. And when I'm running the program inside Visual Studio, the current directory is basically the directory in which my .exe file is there, which you might have seen under bin debug .NET 10. Over there, we will have the .exe file. And beside that, this person.txt is expected to be created. Let me write the data one by one. So this is StreamWriter, and I will write the data as p.name. So first name is written. Then I want to write maybe age. So to write the age, we will use write line p.age. And then likewise, you can also continue writing the address like sw dot write line, and then we can write the address. Please note that this write line function has got so many different overloads. So you can pass the string, you can pass the integer, you can pass the double, we can pass the Boolean value, or any other type, and eventually it will convert your each data into the string and will write it into the file. Not only that, this write line also ensure that after writing each data, it will have one new line character. And at the end, after writing all the data, it is my responsibility that I should be closing this. I will just put one simple statement saying that the file is written or data is saved in the file. Let me run it and check whether such file is created. So this file is created in the directory of exe. You can go to the file explorer and you can check it from there. Or let me show you a shortcut. Inside this Visual Studio, we have option like show all files. When I click show all files, it is also showing me those folders which were created during the build process, like bin folder. Then we have debug folder. Then we have net 10.0 folder. There we have file io.exe. And beside that, person.txt is created, in which this James Bond information is written. And each information is written on a separate line due to write line. If you use only the write function, then it will write the data, but it will not take cursor to the next line. So next data will get written on the same line. It is to be used as per your requirement. Now you understood about the person.txt writing part. Let us write the code for reading part. Let me first highlight that this was writing person data to a text file. And to read the data from the text file, now we can write the code once again. Let me call it as main. And there I will say that read person data from that text file. For that, all I need is StreamReader class. So we have StreamReader, let us call it as SR, and then we can say new StreamReader. We will give path of exactly same file like person.txt. After that, whatever sequence that we have followed while writing the data, like name, age, and address, it is my responsibility that I should read the data in exactly same sequence. And that will be done by saying sr.readLine. It will read the first line. Now my first line was string. So I should read the data and then assign it into the person object. For that, let me create one empty person object first. And this is where I get the name. Now the second part is a bit challenging because while reading from the text file, we have only option of reading the whole line. There is no option for reading the integer from the file. So if I want to read the age, I have to first read the line, then I need to convert it into the integer. That conversion can be done using in.parse or it can be done by using the convert class. So let me write it, age is equal to, we can use in.parse and then we will convert that second line into the integer age. Going ahead, I want to read the address. Luckily, address is string, so no conversion is required. And then I should close that file. So we can close the string by saying sr.close. At the end, let me print the data, whatever is read from the file. So I'm running this and there you get whatever data we wrote earlier is read back and printed very well. Now there is one small thing I want to tell you over here. While writing the data or while reading the data, if something goes wrong and if your code fails due to some exception, which might be at the operating system level, it might be some file permission issue or some other logic that you have written into the code. If that particular code fails in between, then what will happen? Then don't you think that it will never reach to this close part? And if it didn't reach to that close part, then your file is not closed properly. This is referred as resource leakage, which is very bad idea. What is a better thing we can do? Better thing that we can do is we can be prepared that whether there is an exception or not, I always want to close the file. And if you refer our exception handling lecture, then you know that the best way of ensuring that no resources leakage is using the using keyword or using block, where at the end of the block, the dispose method of iDisposable interface will be called, and that ensure that your resource is not leakaged. So let me use that using keyword. And inside this using block, let me write all this code. Now, in this particular case, whenever this using block is finished, automatically the file will be closed. In fact, it will call the method dispose, and this dispose will take care of calling the close. If you also want to handle the exception, then ideally this whole code should be put in the try catch block, and inside catch block you can write the logic to handle that exception. For sake of simplicity, I'm avoiding writing try catch over here. I leave it as a homework for you. But similar thing, I should be doing it for StreamReader also. So this is StreamReader, and again at the end of the block, automatically the open StreamReader will be disposed. It will take care of calling the close method. This is how you can write a very simple code to write the data and read the data from a text file. But as I said, text file has got a little problem that writing data and afterwards mainly reading data, you need the parsing logic, and the parsing is always slow and many times error prone. So it is better if you are looking for performance, then go for the binary write and binary read. For that, we have other set of classes like binary writer and binary reader. So let us take a look at those classes. So here I'm creating a new main, and inside this, let me again create a person object and write the data in binary file. So write person data to a binary file. For that, let me first create a person object, and maybe we can go for same person like James Bond. Then to deal with the binary file, we have the class BinaryWriter. In BinaryWriter, we can say new BinaryWriter. You might have noted earlier that when we go for StreamWriter, we directly return the path of the file. Unfortunately, for BinaryWriter, there is no string path. You have to provide the stream in which you want to write, and you can create such file using the helper method like file.create. Over here, I will not give the file extension as txt because txt is conventional extension for the text file. Here, I'll prefer to write person.b. And now I need to take care that whatever stream is created by this file.create has to be closed. Also, this binary writer has to be closed. And the best method, as we learn already, is using the using block, which will take care of doing the dispose method, which will in turn make a call to the stream dispose method. We need not to dispose the stream explicitly over here. But how exactly you will write the data? That should be very simple. Here we have the method like bw.write. Please note that there is no write line method, only write method, which will write the given value. And again, it has got plenty of overloads like It can write the Boolean value, it can write the string value, it can write the integer value, float value, double value, short value, whatever you talk about. Let me again write the data in the similar sequence where I have first written the name, then I'm writing age, then I'm writing address, and all my data is saved in the binary file. Again, I have not given a path, so it will get created in the same directory where exe is kept, where currently only person.txt is there. When I run this block code, then it will create the file person.bin in the same directory where exe is present. Over here, currently only person.txt is there. But when I run this particular program, it will also create the file person.bin. And since it is a binary file, here you will see it in kind of a hexadecimal format. So if I try to open the file, you will see that some hexadecimal codes it is trying to show you. If you try to open this particular data into a notepad, then in notepad, you might see the strings like James Bond and London. But the actual integer or floating or Boolean data, you will be able to see some garbage because that file is a binary file. How we are going to read the data back from that file? To be frank, the logic is similar. The sequence in which we have written the data, exactly same sequence, we have to read the data back. So let us again create the person object, and then here we will use the binary reader. Here we do not want to create a file. We want to open the file for reading purpose. And this is where the helper method like file.openRead will be useful. Now file.openRead will return me a file stream, which I'm passing it in a constructor of binary reader. And then binary reader will help me reading the string first. Then you can see that directly integer 4 bytes are read from the file and assigned to p.h. And then again, we are reading the string back. At the end, you can display the data. Let me run and check whether we are able to print the data. This is great. Let me assure you that dealing with binary file is definitely faster than dealing with the textual file. So if you do not want to open this particular saved data in Notepad or other text editors, I would always recommend that you should go for the binary file. You should go for BinaryWriter and BinaryReader. Let me explain you what exactly happened behind the scene. In .NET, stream is one abstract class, and a stream object is abstraction of a source of data or sink for the data. So using stream, you can read the bytes from the source, or you can write the data to the sink. This stream is just an abstract concept, but from that stream, there are multiple classes are inherited. You can see that one class is FileStream class, and FileStream class is primarily responsible for writing bytes into the file or reading bytes from the file. For that, stream class has got the write method and read method. But it is not limited to only FileStream. There is also other class like MemoryStream, which is useful for holding the data in memory. Or we have BufferedStream, which will buffer the data before writing it or reading from the underlying stream. Apart from that, there are also interesting streams like network stream, which is useful for sending the data over the network, or crypto stream, which can be used for encryption and decryption logic inside the streams. As I said, all these stream classes are basically inherited from the abstract class System.io.stream. And when we were using the text file StreamWriter and StreamReader, how exactly it was working? Whatever data that we were sending to the StreamWriter, it was first converting it into the string, and that strings were converted into the bytes, and then those bytes were actually sent to the file stream who was responsible for writing it into the file on the disk. And then FileStream was reading those raw bytes from the disk, giving it to the StreamReader, and StreamReader was actually giving us the actual strings. And then if it is needed, then we were converting that strings back to the integer as we had done it using int.parse. As far as binary writer is concerned, the binary writer, again, we are giving some binary data, and then that binary data is given to the writer. It is converted into sequence of byte, like 4 bytes of integer age is converted into 4 byte sequence, which is then given to the file stream, and file stream will actually write it into the file. While reading, file stream read the raw bytes, and those raw bytes are given to the binary reader. And binary reader, depending on the method, if we are using the method like read int32, it will convert those 4 bytes back to integer. Or we are using a method like read string, then it will read it as the string, and so on and so forth. This is how internally the text file and binary files are handled in .NET. This might be a bit tricky many times to the people, but it is worth understanding the actual use of this StreamWriter, StreamReader, and BinaryWriter and BinaryReader. Something common in both of them is we are writing the data in custom sequence, and then we have to follow exactly same sequence while reading the data. Let me tell you one small thing about the file stream, and then we can talk about the serialization. As there are so many streams, this lecture we are focusing only on the file stream. And I shown you that there are helper methods available like file.create or file.openRead or file.open, which can help you to get the object of the file stream. But if you want, you can create the object of the file stream using the new operator. And typically, you need to give at least 2 arguments. One is path and another one is mode. Now see that this mode is an enum, and that enum has got multiple different values. The interesting values are the file mode dot create. Create means you are creating a file. If the file already exists, then you are actually overwriting it. Then there is second option called as a create new. What this create new is doing, which is creating a new file. And if file already exists, then it will give you exception. Then we have open. What open is doing? It is opening the file for you. Whether you want to write or read, that can be decided by using the third argument called as a file access. Then there is an option called as open or create. Means if the file already present, then open it. If the file is not present, then create it. There is also option called a truncate. Truncate means you are opening a file for writing purpose, and whatever existing contents are that, those are deleted from the file. And then there is an option called as append. Append means the file is open for writing, and whatever you will be writing, it will be appended to the file, means it will be written at the end of the file. If you know any other programming language, then you find that such sort of modes are available in every programming language as far as file IO is concerned. Now we talk about the basic file IO. We talked about the text file IO and binary file IO, but then there is very interesting concept called as a serialization and deserialization. Let me remind you, we talked about the object-oriented pillars, and there was a minor pillar called as a persistence. The persistence was about writing or storing the state of the object so that that object can be reconstructed later. Typically, when your program is running, then you can store some data into the objects of the different classes. But when the program is terminated, your object data is lost. If you want to retain that data, then you can try to store the data somewhere into the database, or you can store the data into the file. And that particular stuff is called the persistence. The most effective way of doing persistence is a serialization, where you are converting your object data into sequence of bytes, and then you can store it into some file, or you may even transmit it over the network stream. Why that name is serialization? The serialization talk about the serial. It talks about the sequence of the bytes. That is reason the name is given as a serialization of the bytes. And once you have that sequence of bytes, if you want, you can reconstruct the object with the earlier state. And the reverse process is deserialization, where the object is reconstructed from the serialized sequence of bytes. One common question that many people have is why we are using serialization when we can use BinaryWriter or StreamWriter. Just few minutes back, I told you, if you are using these writers, you need to define the sequence in which you are going to write the fields. And you need to follow exactly same sequence while reading it back. If you have 2-3 data members, then it can be very easy. But what if your one class is having 30-40 data members? Then you need to write all of them one by one manually, and while reading, you have to follow exactly same sequence. So a lot of work that need to be done by the programmer. But serialization is special because in serialization, you are not only writing the data into the file, but you are also writing the metadata. You are also writing the names of the fields, data types of the fields, so that you can serialize the whole object in a single line of code. And whole deserialization can also be done in a single line. One of the most common serialization that was available is BinaryFormatter. The BinaryFormatter is responsible for converting your object into sequence of bytes, and that bytes is representing the raw binary data. The data is written into the file, and data is read back again during deserialization process to reconstruct the object. So you can see that the code is very simple. You have to just create the object of BinaryFormatter, and you have to just call a single line of code like formatter.serialize. You have to tell it in which stream you want to write, and then you have to give the object to be serialized. And then while deserialization, again you have to just give the string, and it will read the data and convert it back to the object. Directly object is given to you. Now it is irrespective of how many data members that you have in that particular class. This particular binary formatter comes from the namespace system.runtime.serialization.formatters.binary. And for that, there are some specific conditions. The number one condition is the class of this object must be having serializable attributes. What is exactly the attribute and how attribute work behind the scene, we will try to cover in some other session. For now, you understand that the attributes are used to associate additional metadata with the class or its members. So over here, our class must be serializable. Moment my class is serializable, all the data members of that particular class can be serialized. If that class is doing composition, and if there is an inner class, then that inner class should also be declared as serializable. But while writing the data, if you do not want certain field to be serialized, like if I'm keeping the username as well as password, and I do not want to store the password into that serialized form, then you may tell it that skip that particular field, and that can be done by using non-serialized. So all fields except non-serialized will get serialized. Then do we use the binary formatter? The earlier versions of .NET, it was very common, but .NET 5 onwards, this is considered to be unsecure and unsafe, and that is the reason it is deprecated. Let me show you some demo of this. Let us go back to the Visual Studio, and inside this we will create our new main. Now again I'm creating the person object. I want to write this person object into the file, but using the binary formatter. So let me mention it. Write data into file using binary formatter. So let us try to create the object of the binary formatter. And as I said, if you want to use binary formatter, you need to import the namespace. And then we are creating an object like formatter is equal to new binary formatter. You can see that it is giving you warning, and .NET 9 onwards, it is even giving you the error. If you want to get rid of this error, as I said, you need to go to the project file, and inside project file, you need to mention that I want to avoid this error. So please enable binary formatter. So you can mention enable unsafe binary formatter serialization. This is opening, closing, and I'll mention true over here. Now you can go back to the program.cs, and ideally now there is no error. As I said, writing code is very easy. You have to first create the object of the file stream. So let me first create the object of file stream, saying that file stream stream is equal to new file stream. Let me give some name. Let's say person2.bin. And over here, I need to give the mode, like FileMode dot create. Now you want to save the data, so you can simply say formatter dot serialize, and then let me put a message. Let's say file is written. Before I run this, let me mark my person class as serializable class. So I'm writing the attribute on this class, and which is mentioning it is serializable. After making the class serializable, let us give a try. And when I run this, you find that the error is still there, saying that binary formatter, serialization and deserialization have been removed. Now let me tell you, if you were there till .NET version 8, then by adding this flag of enable unsafe binary formatter serialization, it was allowing you to perform the binary serialization. However, .NET 9 and 10 completely removed this as a part of the .NET framework. Now, if you at all want it to be used again in your application, though it is not recommended, then you need to install that support explicitly. And to install that support explicitly, you need to use NuGet Package Manager. We will discuss about NuGet Package Manager sometime later, but for now, let me show you the process. So you can go to the project properties, and into the project properties, you can click on Manage NuGet Packages. Let us go to the browse and try to find out the formatter package. You need to search that package on internet. Let's say formatter, and if you find this formatters package, then we can download and install it into our project. So click on install. The latest version available was 10.0.3. We can click on apply. Now this separate class library is downloaded by NuGet. Its reference is added in our project, and now the binary formatter should be available. Let me close this NuGet manager. You can also see that in my project file, there is package reference added. And now we can go back to our code and run it once again. Now you will find that actual file is written. The name of the file was person2.bin, and you find that such file is created. As I said that it is a binary file. So if you check inside this, the whole data is in binary, and you can see certain information over here. Like you can see the name of the class, and you can see the actual name of the fields, talking about the names backing field, age backing field, address backing field. This is basically the metadata. And then you can see some data over here like James Bond London. Though you are not able to read the exact data due to the binary, but at least you can get a little idea looking at this file. And how do you read this data back? So reading that data back is as simple. Like again, we can use read data back using binary formatter. And again, I will use FileStream. We will open the file. We will use formatter.deserialize. Please check that deserialize return type is object. So you need to downcast it to the person, and then you can print it back. Let me run this and check if it is working. Again, the file was overwritten, and then the data was read back. Let me highlight over here. Though I have taught you binary formatter, no way I recommend using these legacy formatters like binary formatter or SOAP formatter. I covered them over here only for the academic reasons. There are certain academic institutes where people are still giving exams, and binary formatter happens to be one of the question. Not only binary formatter, but also serializable attribute. And as I said, we can also have attribute called as a non-serialized attribute, where you can have some data, let's say public int id, but I do not want to store that data into the file. I do not want to serialize that. Then I should use the attribute non-serialized, and that attribute should be used on the particular field which you do not want to store. By default, all the fields data is stored and then retrieved back. If I'm not supposed to use the binary formatter or legacy SOAP formatter, then which formatters I should use? Then there are options like you can go for XML serializer. And using XML serializer, you can serialize the data in the XML format. There you will find that whatever field names are given, based on those names, actual XML tags are created and data is stored inside those XML tags. You know that XML is basically the text format. So you can read it well using any text editor. Not only that, XML is also the cross-platform or platform-independent format. So you can write the data in XML format using .NET, and you can use other language like Python or Java for reading the data back. So that advantage you can get it using XML format. But I believe that you will be aware that in recent year, instead of XML, people are preferring the other format, and that is nothing but JSON. JSON stands for JavaScript Object Notation. And this JSON is also a cross-platform interoperable format where you are storing the data in the JSON format, which is basically a key value pair. And this JSON data usually needs the less bytes to represent the same data with respect to XML. For that, there is the ready-made class available called as a JSON Serializer in System.Text.Json, and this is very much part of the .NET framework. You can also note that JSON Serializer is a bit different because it has got static method serialize and deserialize. So there is no need to create the separate object as we have created in BinaryFormatter, or we can create it for XML serializer. Here we can directly say JSON Serializer dot serialize or dot deserialize. Let me show you the demo of JSON Serializer over here. So let me go back, and over here we will continue the same person object. So let me create a new main. Over here I want to write the data into the JSON format. So write data in file using JSON Serializer. So let us create the FileStream object first. I'll use using FileStream, and we are creating .json file over here, person.json. You can give any extension. You may use even .txt extension, but I prefer using the .json extension. Then I want to create like JSON Serializer .serialize, JSON Serializer, and we have directly the static method serialize. There again we are passing the string and we are passing the object to be serialized. If that serialization goes well, we will print a message console.writeLine. As I said, you should write the try catch block and ensure that if there is any exception, you should be handling that. For sake of simplicity, let me run it. And here you see that file is written. Let me check whether person.json is created. And inside this person.json, you can see that the data is stored in a JSON format. Here, name, age, and address, these are the field names, and James Bond 32 and London, these are the actual values. Let us go ahead. How do I read this data back? Now to read this data back, we will write another main. Again, we will read the data from file using JSON Serializer. Again, I'm creating the file stream. Over here, I will use the FileMode.open, and then I will use JSON Serializer .deserialize. Please note that this deserialize is the generic method, and I need to tell the JSON Serializer that whatever data is read, it is to be converted into object of which class, and that information we have provided over here. Then it will read the data from the stream, then convert it into the person object, and it will give me the result back. So let me run this, and you will see that the same data is read back. Let me go ahead. If you want to change the JSON field name inside the JSON file, then you can use certain special attributes. Let me change the name of this field using JSON property name. And over there, instead of giving, let's say, name, let me use, let's say, person name. Again, if you want to change the age, let me change it like JSON property name, and I'm writing, let's say, person age. Exactly same name will be present into the JSON file. You might be also interested in not writing certain data into the JSON file altogether. If you want that, then this special attribute available called as JSON ignore, so that this particular field is ignored. It is not written, even it is not read. Let me try this out. Let me go back to this code, and I'll first write the data into the file, and then I will read it back. So let me first run this, and now person.json is created once again. You can check this person.json is now having only the name and age. It is not having the address because it is ignored. Also, you can see the field names are modified. Now, While reading back, let me again comment this and open this reader. Let me run this and you'll find that it has got the data, name and age. The address data is not received because again the data is ignored by the JSON deserializer. This is how the JSON writing or JSON reading is possible. As you go ahead with the web technologies, you will typically use REST APIs, and REST APIs are sending and receiving data in the JSON format. When you get the JSON from a REST API, you can again use same JSON Serializer .deserialize method to actually read the data back. So this concludes our file IO lecture. Here we talked about the helper classes. We talked about the text file write and read operation. We discussed binary file write and read operation. We also understood the stream concept and we seen the important file stream modes. Then we talked about the serialization and deserialization core concept. We discussed academic binary formatter. I told you about XML serializer, and most importantly, we talked about JSON Serializer, which you will need in future as you start dealing with the REST APIs. I hope you found this particular session useful, and this will help you to conquer the file IO in the .NET. Thank you for listening so patiently. See you in the next session. Bye bye.